Hello students, in this part we are going to discuss about a very important topic, that is limiting reagent and is also known as limiting reactant. So how to find which is the limiting reagent in a chemical reaction and what is its significance. To know all these things we have to go through this particular part. So let's start. So now let's understand the concept of limiting reagent, which is very important. Which is very important for JEE purpose, and it is also important for solving numericals based upon the stoichiometry. Okay. So first understand what is meant by limiting reagent. So we can also call this limiting reagent as limiting reactant. It is going to be one of the reactants involved in the reaction. So what is the limiting reagent? So if you see the name, if you decode the name, the limiting reagent or limiting reactant. So it is a reactant that limits the reaction. What is meant by limiting a reaction? Limiting a reaction means it is a reagent or reactant that controls the extent to which a chemical reaction takes place. Okay? So basically it is the one which stops the reaction. So that's why the name is given as limiting reagent, since it is the only reactant that limits any reaction, Okay? So it decides the extent of reaction and the amount of products formed, which is very important. The limiting reagent is the one which controls the amount of products formed in any reaction. Okay? So this concept of the limiting reagent is valid for chemical reactions which involve more than one reactant. That is, at least two reactants should be there, and two or more than two should be present in the reacting mixture. Okay? So if you take only one reactant, then the concept of limiting reagent is not applicable. Okay? Because if there is only one reactant, then there is no concept of this limiting reagent. Okay? So let's understand the concept of the limiting reagent from our daily life example. Okay? So the example which I am presenting here is a very simple one. So here how many t-shirts I have taken? I have taken 4 t-shirts and there are 2 pants, right? So 4 t-shirts I have taken, 2 pants I have taken, and I want to make pairs using 1 t-shirt and 1 pant. Okay? So tell me how many maximum number of pairs that is possible for me to make. Maximum number of pairs. The answer is simple. Only 2 pairs you can make. Maximum 2 you can make, because you have only 2 pants. Though you have 4 t-shirts, but out of 4 t-shirts, only 2 t-shirts are going to be used up and 2 pants are going to be used up. So maximum you are going to prepare only 2 pairs. And what are the 2 t-shirts we have? These are excess. We cannot make a pair because we don't have enough pants. Okay? So these are the pants which are not enough and which are controlling the number of pairs that you can possibly make. Okay? So this is the one which is present in excess amount, and this is the one which is present in the limited amount, right? So this is going to be my limiting reagent, and this is going to be my excess reagent, right? Okay? So if I take this as a chemical reaction that is taking place between these t-shirts and these pants, if I take it as a chemical reaction, then in that chemical reaction the pants is going to be my limiting reagent, which are fully consumed up, and this is my excess one, the one which is present in excess quantity. Okay? So here if you see, I don't have any pants left out, but still I have some shirts left out. So this is present in excess quantity. Okay? So let's applicable, this thing is also applicable for a chemical reaction. Okay? So if I take a chemical reaction that is occurring between A and B, and it is giving some product, say suppose C and D, right? Okay? So what do you understand by this chemical reaction? Here what you need to understand is, for products to form, A has to react with B, that is P is also reacting with K, both the same. So A need B and B also need A. If both are present, then only the reaction takes place. Say suppose the reaction is proceeding and A is completely consumed. So no amount of A is left out in the container, only B is left. If only B is left, then B alone cannot make the reaction possible. The reaction is going to be stopped. So alone B cannot do anything and alone A cannot do anything. So the extent to which the reaction takes place is depending upon which is consumed first. Say suppose if A is consumed first, then A is going to be my limiting reagent because it is going to stop the reaction. Okay. So if I take B is in small quantity and it is consumed, and after some time no amount of B left out. So since the absence of B makes this reaction does not occur, so B is going to be my limiting reagent because it is the one which is limiting the reagent. Okay. So this is the concept of limiting reagent. So let's understand more about it. Yeah. So let's take this example. In this I have taken 10 hydrogen molecules and 7 oxygen molecules I have taken, and as a result I got 10 water molecules and 2 oxygen molecules. So let's understand what is the limiting reagent in this chemical reaction. This is the situation before the reaction and this is the situation after the reaction. Okay. So if you recollect the reaction between hydrogen and oxygen, and it is forming water molecules, so H2O, so 2H2 plus O2 gives rise to 2H2O. This is the balanced chemical equations, right? Balanced chemical equation. So here if you see, the 2 moles will react with 1 mole and it forms 2 moles, right? So 2 molecules will react with 1 molecule and it forms 2 molecules. But here I have taken 10 molecules of hydrogen, I have taken 7 molecules of oxygen, and as a result I am getting 10 water molecules and 2 oxygen molecules are still left out. So here 2 molecules is requires 2 molecules require 1 molecule for the reaction. So here I am taking 10 molecules. So simply multiply this with 5. So what will get? The 10 molecules will actually require only 5 molecules. 5 molecules are required amount, but here I am taking 7 molecules. That means 2 molecules are going to be extra. So these are the 2 extra molecules. Okay. So oxygen is going to be my excess reagent, and other than oxygen we have hydrogen. So hydrogen is going to be my limiting reagent. Okay. So in any reaction, if one is involving 2 reagents, if one is excess reagent, then obviously other is going to be my limiting reagent. Okay. So if you want to find out which is the limiting reagent, you can do it in both the ways. You can find out the limiting reagent directly, or you can find out the excess reagent. So one is excess reagent, so other one is obviously going to be the limiting reagent. So in this case, my hydrogen is my limiting reagent and oxygen is my excess reagent. Okay. Yeah, if you see the problem solving strategy involving the limiting reactant or limiting reagent. Okay. So there are many numericals can be asked from this limiting reagent concept. So let's see the methodology to calculate, to find which is the limiting reagent and to find out the amount of the products formed in any chemical reaction. First of all, what you need to do is write the balance equation first. That is the first step of solving any question. From the balance equation, convert into moles. That means, say suppose if the masses of the reactants are given, convert those masses into mass of the reactants into number of moles. Okay. So it is essential to convert that mass into number of moles, and from that number of moles you can identify the limiting reagent, which I discussed in the previous case. You can identify the limiting reagent, and since the limiting reagent is the one which is going to control the reaction and which affects the amount of the products formed. So from the limiting reagent you can calculate the amount of the products formed, right? So you can calculate the amounts of product formed based on the amount of the limiting reactant you have taken. Okay. So you can calculate the amount of the products formed, and you can convert the amount of product formed into mass, like volume or particles, like depending upon what is asked in the question. If they ask particles, you can convert the number of moles of the products into volume or particles, etc. Okay. So this is the solution methodology to solve any question that is based upon the concept of limiting reactant. Okay. So like the question will ask you, like they will give you masses of the reactants and they will ask you what is the masses of certain product form. Okay. So to find the mass of certain product, first of all you need to identify which is the limiting reagent. Okay. So after identifying the limiting reagent, forget about the excess one. Excess one is not at all important for us. So only concentrate on the limiting reagent. So calculate how much product can be formed on the basis of the amount of limiting reactant that you have taken. Okay. So this is the solution methodology to solve any question on the basis of the limiting reactant. Now we will see a demonstration on the limiting reagent concept which we discussed just before. Here I am taking a reaction between the metallic zinc and hydrochloric acid, which is giving zinc chloride and hydrogen. Zinc chloride is soluble in water and hydrogen gases evolved in the reaction. So here there are quite few things that we need to observe. Is we have taken zinc in different amounts. Zinc is taken in variable amount, but the amount of hydrochloric acid is same in all these three reactions. We have taken these three reactions. So we need to observe some important things. One is to see whether the zinc is consumed completely in all the reactions, or in any reaction zinc is not completely consumed or something is left out. So that is one thing that we need to observe. And other thing that we need to observe is the hydrogen gas which is liberated in equal volumes or in different volumes in these three reactions. So these are the important observations that we need to make here. So let's see what happens during the reaction. And here we have attached a balloon here. So whenever the hydrogen gas is formed, this balloon expands. So from the expansion of the balloon, we will understand that how much volume of the hydrogen gas is liberated. So here three reactions we are carrying on, and we are dissolving different amounts of the zinc in both the solution. As the reaction proceeds, you will see at the left end, at this leftmost part, you will see some amount of the zinc is still remain, and at the rightmost reaction we have seen all zinc is consumed up, and the amount of hydrogen gas that is formed is also less as compared to the other two reactions. Okay. So let's understand about the concept of limiting reagent in this. So let's take the middle one. If you take the middle one, no amount of zinc is left out here, and the volume of the hydrogen gas is formed, then that is maximum. So here we have taken zinc and hydrogen chloride in the correct mole ratio. That means we have taken 1 mole of zinc and we have taken 2 moles of HCl. So as a result, we got 1 mole of hydrogen gas. 1 mole of hydrogen gas we got, because if you take 1 mole of zinc and 2 moles of HCl, we will get 1 mole of hydrogen gas. That is what we observe in the middle reaction. And if you observe on the leftmost part, on this part, if you observe here, some amount of the zinc is still left out. You can see zinc remains here, and the hydrogen gas which is liberated is maximum. Okay. So this is the important observation that you have to make in this, that some amount of the zinc is still left out. That means zinc is taken in excess amount. Zinc is the excess reagent. So if zinc is excess reagent, then obviously HCl is going to be the limiting reagent. This is the important observation that we made in the leftmost part. So if you observe, if you compare these two, the first and second reactions, the volume of the hydrogen gas is liberated is same, and this volume of the gas liberated, the volume of the product formed is entirely depends upon the amount of the limiting reactant that you have taken. Since here in both the cases the limiting reactant is hydrogen chloride, HCl, so we have taken that HCl in the same amount, so we will get the hydrogen gas in the same amount. The same amount of the hydrogen gas is evolved. That you can see the volume of both these balloons are equal. So from this we can conclude that HCl is the limiting reagent in both the reactions. But however, if you take the rightmost part in this particular reaction, zinc is present in insufficient amount. That's why the volume of the hydrogen gas is liberated in this case is less than the volume liberated in the rest other two cases, which implies that zinc is the limiting reagent in this case, in which it is completely consumed up. Okay. So these are the important observations that we made, and we identified what is the limiting reagent, right. So to understand this limiting reagent concept further, to understand it more further quantitatively, let's take an example. Here we are considering the reaction between the solid aluminum and the liquid bromine, and we are getting Al2Br6 as the product of the reaction. Say suppose we are taking an example like this. So here this is the reaction that is a balanced reaction, and this is a problem, that is 3 moles of aluminum we are taking and 3 moles of bromine we are taking, and we want to find out which is the limiting reagent. Is it aluminum or is it bromine? That we want to find out. So let's see how this can be solved. So here 3 moles we are taking, but as per the reaction, if you see, the 2 moles of aluminum actually require 3 moles of 2 moles of aluminum is required 3 moles of bromine. Okay. So if I take 1 mole of aluminum, that requires 3/2 moles of bromine, that is 1.5 moles of bromine. So 1 mole requires 1.5 moles. So 3 moles aluminum you have taken. So that means the 3 moles of aluminum requires 4.5 moles of bromine. Okay. So this is one thing that we understand from the reaction. So here the 3 moles of aluminum requires 4.5 moles of bromine. Okay. So this problem you can also see in other way, that is, if you see, 3 moles of bromine requires 2 moles of aluminum. That means 1 mole of bromine requires 2/3 moles of aluminum, but we have taken 3 moles of bromine. So 1 mole requires 2/3 moles, then 3 moles will obviously requires 3 into 2/3, that is 2 moles of aluminum is required in the second case. Okay. So here this much is the amount of bromine required, and here this much is the amount of the aluminum required. Okay. So you can use both these things to find out which is the limiting reagent. So if I go through from the first approach, here I require 4.5 moles of bromine, but I have taken only 3 moles. So that means this is present in insufficient amount, the limiting amount. So bromine is going to be the limiting amount as from the first approach. So if I go through the second approach, here the 2 moles of aluminum I require. To require 3 moles of bromine is actually requiring 2 moles of aluminum, but I have taken 3 moles. That means 1 mole I have taken extra. So aluminum is going to be my excess reagent. So bromine is going to be my limiting reagent. So you can do it in both the ways, and through either way you can get that bromine is the one which is present in the limited amount. So bromine is going to be our limiting reagent. Okay. So this is the way we have to solve the problems based on the limiting reagent. Okay. So in the amount of the product form, that can be calculated from the limiting reagent one. Limiting reagent decides the amount of the product form. So here in this example, the bromine is the limiting reagent and aluminum is the excess reagent. That you can understand from any of the approach. You can follow the approach that you are more comfortable in. So this is about the concept of limiting reagent, and we discussed about how to find the limiting reagent and what is the solution methodology which involves the concept of limiting reagent. While studying this chapter, if you get any doubts, you can post it for free on askIITians.com. How? First, open the website, and if you see at the top right, you will see a discussion board. So simply click on that. It will take you to the next screen. Yeah. In the next screen, you will see the Ask Experts, a separate section on the right hand side. So select a relevant category for your question and simply post your question here. We experts at askIITians will provide answers to your questions within 24 to 48 hours. So students, in this part we discussed about limiting reagent. We understand what is limiting reagent and how to find what is the limiting reagent in any chemical reaction through different examples. So these are the things that we discussed in this particular part. Say suppose you prepared one sugar solution in your home and you want to express the sweetness of the solution numerically. How could you do? It sounds interesting, right? So to know more about it, stay tuned for my next part.